Alright, in this video we are going to graph this rational function right here. I always like to start off with the horizontal asymptote, which depends on the degree of the numerator and the denominator. We have to figure out which one of these three situations we're in. If the numerator degree is less, then the horizontal asymptote is y equals 0. If the degree of the numerator is equal, then that's when we divide the leading coefficients. And if the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. But in that case, there would probably be a slant asymptote. But we'll worry about that more once we see what we're looking at. So, looking at this, the whole degree situation, the top degree is 1. The bottom degree is 2. So the degree of the numerator is less. And when the degree of the numerator is less, then the asymptote is y equals 0, the horizontal asymptote. So that's what we have. So we know our horizontal asymptote is going to be y equals 0. So we can go ahead and graph that as well. Alright, y equals 0, that's just the x-axis. So we're going to have a horizontal asymptote just like this. Okay, so there's our horizontal asymptote. You will never have a horizontal asymptote and a slant asymptote. So slant asymptote, none. Okay, in order to have a slant asymptote, the degree of the numerator had to be 1 greater than the denominator. Well, that didn't happen, so no slant asymptote. Let's go back and talk about vertical asymptote now. When does that happen? To find a vertical asymptote, we're going to set the denominator equal to 0. Okay, it's important to make sure that nothing cancels out, but yeah, there's nothing to factor here. So to find vertical asymptotes, we're going to set the denominator equal to 0 and solve. So basically, if I factor the denominator out, this is the difference of two squares. This factors as x plus 2 times x minus 2. Okay, if I set these equal to 0, I'm going to get x equals negative 2 and x equals positive 2. These are my vertical asymptotes, which I will go ahead and record over here. So we have a vertical asymptote at x equals negative 2 and x equals positive 2. By the way, make sure that you put x equals in front of it. Don't just put negative 2 and positive 2. It has to be x equals. Same here, don't just put 0, it has to be y equals 0. Alright, so might as well graph these vertical asymptotes as well at negative 2 and positive 2. Alright, so here we have our vertical asymptotes. What's next? It's time to find our y-intercept and our x-intercept. Now, remember, the y-intercept is always 0 comma something, and the x-intercept is always something comma 0. So in other words, if I want to find the y-intercept, go ahead and let x be 0. If you want to find the x-intercept, let y be 0. Okay, so let's do that. So if I want to find the y-intercept, I'm going to let x be 0. So looking back at the equation, that means put in 0 for these x's. So let me just erase all this mess. If I put in 0 for these x's, and by the way, this f of x basically holds the position of y. So for now, I'm going to go ahead and actually call it y. Okay, so now I'm going to let x be 0 so I can find the y-intercept. So if I put in 0 here and here, alright, then that gives me y equals 0 over negative 4. which gives me y equals 0. So this is going to be my y-intercept. Okay, so in other words, 0, comma 0. And I might as well graph that. All right, my y-intercept is going to be right here. Do not panic. Some of you believe that you can't touch the horizontal asymptote. That is false. You can have a point on the horizontal asymptote. You can't have any points on the vertical asymptote, but you can cross the horizontal asymptote. The horizontal asymptote will ultimately show us the end behavior. You know, we might have a graph going like this or doing something like this, but whatever's happening in the middle, you can cross it. It happens, not a big deal. So don't freak out that we have a point on the horizontal asymptote. It's okay. So anyway, we graph that. Now, x-intercept. Like I said, if you want the x-intercept, let y equal 0 and solve. So what am I talking about? So I'm saying let y equal 0. So here's y right here. So we can let y equal, that's too big. We can let y equal 0 by putting 0 right here. In other words, we're setting the entire function equal to 0. In fact, I'm sure you don't care whether I have the 0 on the left like this or if I put the 0 over here on the right. It's the same difference. Okay, either way, the thing I'm going to do next is I'm going to multiply both sides by x squared minus 4. Okay, maybe I'm just going to recopy the whole thing for a second. So what I have is I've got x over x squared minus 4 equals 0. I just flip this around. I can multiply by the denominator. So if I do that, if I multiply by x squared minus 4 on the left and x squared minus 4 on the right, the x squared minus 4 cancels out. Now that's going to leave me on the left. Now I just have x equals. But guess what? 0 times anything is 0. So that leaves me with just x equals 0. So this is going to be my x-intercept. Alright, so I'm going to have 0 here. So my x-intercept and my y-intercept are both 0, 0. And so that's my only x-intercept. Sometimes there's more than one. So this really is enough information for me to find the domain. You don't need the graph in order to find the domain. You need to know if there are any holes. Okay, and there are no spaces on here for holes, but there are no holes. Remember, holes happen when something cancels out. There are no factors here that cancel out, so there are no holes. So that only leaves vertical asymptotes to break up the graph. Okay, only these vertical asymptotes are my discontinuities. So that means to focus your eyes on the vertical asymptotes. When we talk about domain, it's going to go like this. All right, coming in from negative infinity. All right, I'm going left to right across the page. The first part of my domain is going to go from negative infinity up to negative 2. And then the next part of my domain is going to go from negative 2 to positive 2. And the last part of my domain is going to go from positive 2 to positive infinity. So this is what my domain is going to be like. Alright, so like I said, here it goes. So my domain, here comes the yellow part, negative infinity to negative 2. Alright, union. Now here comes the green part, negative 2 to positive 2. Now here comes the pink part. Union, positive 2 to infinity. The domain is always going to start with negative infinity and end with positive infinity. And in between, you're going to pause at any discontinuities, either vertical asymptotes or if there was a hole, I would have stopped and and start it again afterwards. So there's my domain. So the range is more complicated than that, and I will need the graph to know what the range is. Okay, so to make the graph, I'm going to need several points. So as I choose my points, a lot of kids are like, Mr. Burton, how do I know what points to pick? It's all about the vertical asymptotes. I have a vertical asymptote at -2, and I have a vertical asymptote at +2. So I'm going to need a few values to the left. I'm going to need a few values in the middle, and I'm going to need a few values on the right. But there are two secrets that I want you to lean in and listen carefully. I'm going to tell you the two secrets. The first secret of picking your values is always pick values that are close to the asymptote as some of your values. So if I have a vertical asymptote at -2, I'm going to go just a little bit to the left of -2 and a little bit to the right. I'm talking about decimals to the left and decimals to the right. So for example, to the left of -2 would be -2.5. So I'm going to definitely use -2.5 as one of my values. A little bit to the right of -2 would be -1.5. So I'm definitely going to use -1.5 as one of my values. Okay, now over here I've got a +2. Again, I'm going to go a little bit to the left and a little bit to the right, and I'm definitely going to use that. So a little bit to the left is 1.5, so I'm going to use that. A little bit to the right is 2.5, so I'm going to use that. Hey, what happened to my my x and y intercept point disappeared? I'm going to have to put that back again. Maybe I'll do that right now. Please stand by. This train is departing. Okay, stay. So always use these decimals that are a little bit to the left and right of each vertical asymptote. After that, that was the first secret, using those decimals. The second secret is this: use lots and lots of points. Graph as many points as you can. It doesn't matter that I only have a few more spaces on my table. You can plot as many points as you want. They're free. Okay, don't be stingy. The TI-30 XS Multiview just cranks them out like crazy. So don't just sit there going, I'm just going to plot like 3 points. No. Plot 100 points. I don't care. So anyway, let's go ahead and get the function in the calculator. So what was that function again? X over x squared minus 4. So here we go. We have x over x squared minus 4. Okay, so in addition to these decimals, I'm going to use, I said I wanted a few points on the left. So I have a decimal here, but I'm going to go ahead and also use -3 and -4 as points. Okay, I have this decimal right here, but I'm also going to use -1. And right now, I don't want you sitting there thinking, how's he picking these? I'm just picking everything, okay? I mean, I showed you how I got the decimals, but beyond that, just pick a bunch of points all over the place. So there's no magic science to picking these points. Just pick a bunch. All right, just make sure you have some in every region, left, center, and right. So I said I'm going to do -1. I've already got that point. I'm going to do +1. So I've got that. To the right of the asymptote, I've already got the decimal, so I'm just going to do a couple more. So I'll do 3 and 4. Okay, so all of these x values, this would be a good crop of points to use. Okay, so in order to get the decimals, an easy thing to do is make sure your calculator is in ask mode. Ask mode. So mine is, so I'm good to go. So let's see. So I need negative 2.5, negative 1.5. Okay, negative 2.5, negative 1.5, and 1.5. Okay, so I've got these. Okay, negative 10 over 9, that's negative 1.1. Okay, and then I already know, let's see, 6/7, that's basically 0.9 if I round up. And that's positive. That means this next one is negative 0.9. Okay, what about 2.5? That's the only one I don't have. It's the only decimal I'm missing, so 2.5. Okay, so that's 10 over 9. We already saw what that was, but this time it's a positive 1.1. So there, I've got all those decimals. All right, after that, it might be easier to get the rest of these values in auto mode. So if I go back to my calculator, hit the table button, hit enter, I might switch the calculator back to auto mode now. Okay, so where am I? So I'm at like -3, -4 and such. Okay, so at -4 I've got -1/3. Okay, and I know that -1/3 is basically -0.3. -3/5 is -0.6. Okay, and let's see. At -1, that's 1/3. All right, that's 0.3 again. At +1, all right, there's 0, 0. That was our x and y intercept. That's -1/3 again. So that's -0.3. At 3, we're at 3/5 again. So that's 0.6. And finally at 4, we're at 1/3 again, which is 0.3. Okay, so armed with all these points, let's just graph them all, and that will give us a very good idea of what this graph is going to look like. I'm going to plot these off camera and then come back to you. Alright, I want to show you this because this might happen to you. Alright, because I'm a human being, you're a human being. Now look at these points that I just plotted. This is just my cursor, don't count this, but do any of these points look like they are wrong to you? Do you see anything wrong here? All these points look fine. I see that the graph is sort of swerving over here towards this asymptote. It's going through and I see it moving towards this. Over here I see a nice little curve happening. It's getting closer to this asymptote, closer to that asymptote. This looks weird. Something's wrong over here. Okay, it's getting closer to the asymptote and then further away. That shouldn't happen. That shouldn't happen. So at least one of these points are wrong. So watch out for that. You know, if you know that it should be getting closer to the asymptote, and then you have a point that's moving further away instead of getting closer, you know, double check it. So I have a feeling my -4, see, for -4 I have -0.6. Maybe I read that wrong. So I'm going to go back and check again and see something looks wrong. Okay, I don't know why I put -0.6, but -4 is -1/3. Okay, that's my -0.3. So I made a mistake there. Okay, so that should be my -0.3. Hold on. Okay, so now I'm thinking my -3 is probably wrong. So my -3 is my -0.6. So I had those backwards somehow. Oh, you know what? Probably because they're in like reverse order. Anyway, so my -3, this should be my -0.6. Okay, so just watch out for that. You know, if it doesn't make sense, double check it. So I'm just going to change these points real quick. Okay, so at -3, I should be at -0.6. And then at -4, I should be at -0.3. Alright, now it makes a nice curve moving closer to the asymptote. Alright, in fact, I'll go ahead and off camera draw these curves approaching the asymptote. But one's going to be like this, one's going to go like this, and one's going to go like this. Alright, so your graph should look something like this. Now I can talk about the range. We read the range from bottom to top. Okay, when I do the range goes from bottom to top. I like to picture a horizontal line that I'm going to use to sweep along my graph from bottom to top. Okay, so here's my horizontal line that I'm going to use. The graph starts off down here at -infinity, and it's going to sweep up, and I'm still touching the graph. I'm touching the graph. The graph is going, still going. All right, even right here at the asymptote, do I have any points on the graph that are on this asymptote? Sure, right here. All right, this middle portion of the graph goes right through here, even the asymptote. So I don't have to skip over it like I sometimes do. And I just keep going up, 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 and forever. So this graph stretches from -infinity to +infinity. There's no place I could put this bar where I'm not touching a point on the graph. Alright, so that's why the range is going to go from -infinity to +infinity. Okay, let's talk about increasing and decreasing intervals. Now, please remember that these are x values that we're talking about. X values. First of all, anything that is decreasing, I'm going to change the color to pink. So this part of the graph right here, well, you know, I changed my mind because the entire graph is decreasing. If you look at this branch right here, from left to right, it's going down. What about this middle branch? I'd have to start here because I'm starting from the left, and it's going down. And look at this branch over here on the right. I'd have to start here, and it's falling down. Every part of this graph is going down from left to right. It's all decreasing. So increasing intervals, I'm going to say none, because no part of this graph is going uphill. For decreasing, all of the intervals are decreasing. So it's decreasing over the entire domain. So the decreasing intervals are just going to be a copy of the domain. Alright, it's -infinity to -2, -2 to +2, and 2 to infinity. Alright, it's the entire graph. Alright, now how about end behavior? A lot of kids get tripped up on end behavior because somehow they want to talk about what's happening here, what's happening here, what's going on. All this is like the middle of the graph. Just for a quick second, I'm going to scribble it out to make a point. Alright, end behavior doesn't have anything to do with this part of the graph right here. Alright, ignore it. The only part of the graph that matters for end behavior is the far left and the far right. Alright, those two yellow positions represent my end behavior. And guess what? If there's a horizontal asymptote, then that's going to tell you your end behavior, because as I go to the left, I'm approaching 0, the horizontal asymptote, right here. Okay, as I go to the right, the function is falling down towards, again, 0, the horizontal asymptote. Okay, so if you have a horizontal asymptote, 0, that's going to show up at the end of your end behavior every time. 0 and 0. And that is the end of problem number 10. Kind of rhymed. I will see you on the next problem.